Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. In this video, we are going to dive into preparing a model for hosting and serving in Ollama ecosystem. In order to make your model to be served through Ollama, you have to do a couple of things. You have to first of all convert the model to gguf, quantize that model, then create a model file. Using that model file, you have to update that to the Ollama namespace. All these process has been explained here. We will be going through these. You don't need to read this. We will be going through these steps one by one in this discussion, and we will be working with a new model that has been released by Big Code called as Starcoder 15 billion version. This notebook that you are looking right now will be shared with you, and also the process that you see here, this is the process that I have taken from this particular document. In order to visit this, in order to get this document of importing a new model, you have to visit the Ollama GitHub repo, go to the docs folder, and inside that there is an option called as import.md. Not an option, it's a file, markdown file. You can review this. I am following this steps only, but there are a couple of challenges and also things that are a little bit different. So I will not be using this option of git lfs. I will be using a different method. That method is what I am showing here. I'll be using the Huggingface Hub import method, Huggingface Hub model download method, instead of using the git lfs. The reason is, in case of Huggingface Hub model download method, you can see how much the model has been downloaded and you can resume the download. So there are a couple of advantages I will explain to you. So this is the overview. So now let's dive into this Jupyter notebook. And yeah, so here these are the various steps, but before we go into the Jupyter notebook, I just want to review the steps again. So you can see that I have to install llama.cpp, and for installing llama.cpp in our local machine, we have to follow this process. I have to clone the Ollama repository and install the llama.cpp quantize application. So this I need to complete, and then I need to use that quantize application and the convert.py application to convert my model and also quantize it. And then I have to create a makefile and use that makefile to load that model into Ollama. So these are the three steps, major steps. Now I am going to go into this A1 step. So once I complete this A1 step, I will go to the A step. Here you see that I'm importing the transformers classes for loading a model. I will be loading the Starcoder model using bits and bytes. You can see the version of transformers that you need to use is 4.39.0 dev 0. So this is actually a development version that you need to install it from the transformers GitHub option. So in order to do that, you can there are lots of notes available, but if you go to Huggingface Hub and if you look for Big Code Starcoder 15 billion, once you do that, if you scroll down, you will see that how you can use this. So they explain this. You have to use this particular command in order to get the latest transformers version, and then you can start using this particular notebook. So that's very important. I am using this Starcoder 7 billion option, and I'm going to get the tokenizer. And the point is, I've already downloaded the model to my local machine because I've already tested it. So you'll not see any kind of the progress bars here because it's already downloaded. I'm going to load the model in 4-bit and with torch bfloat 16 compute data type for the parameters. And here is where the difference is. So what will happen is, I am going to download the Starcoder 7 billion with the quantization shown above, and it is going to map automatically to my devices. and this part, resume download equal to true. So what will happen is, in case if your internet is not stable, or if you're having a very low speed internet, where I mean, this particular model, if you go and check the file, you will see that it's a very, very huge model. So it's almost you can excuse me, I think I'm opening a wrong one, so I need to open the 7 billion version. Just a minute. Starcoder, yeah, Starcoder 7 billion version. So if you take a look at the Starcoder 7 billion version, you'll see that it is having almost 15 GB of safe tensors parameters file. So it's going to take considerable amount of time. Even if you have high speed T1 connection, it will still take time, right? It might, the connection might drop and you might lose the memory that you have downloaded. So resume download equal to true option can be used. Once you use this, the challenge with this particular method is that the model is downloaded to a cache folder. So you can see that the shards that I've already downloaded gets loaded to my checkpoint, and you can see that after my model gets loaded, you will see the update in my NVIDIA graphics card here, because I've used the what is it called, device map equal to auto. So here you are not seeing it. Just a minute, I'm executing it right now. So you can see that the model has been loaded. So 6 GB of RAM is being used. Now that is how you actually get the model and load the model. Also, let me show a basic what is it called, code execution, so that you can see what is happening. So the Starcoder model is a code generation model, and it can provide the code. So what you'll do is you'll use the same kind of testing when we are going to work on the Ollama also. So the same prompt we'll be using. So you can see that I'm asking it to provide the code for connecting with YouTube API, and the output is not that great. Okay, the idea is not about the output or how the model is functioning. The idea is that how you load the model to Ollama, and how are we going to go through this process of getting the model through Huggingface Hub Python code. So that's the idea. So you have got the model right now, so you have checked the model. Next, what you are going to do is we are going to hit the command prompt. In the command prompt, the important point is that first of all you need to start installing the ollama llama.cpp library. So for that, you will have to ensure that you are on your home folder. I have created a folder called as git folder, inside which I have done the git clone of ollama. Excuse me, let me actually zoom in a bit. And also what I'm planning to do is I'm going to divide my window so that you can clearly see what is happening. What I have done is I have to do this step. So I have to do the git clone of Ollama repository. So already I have done that. That's how I have tested it. So I am already inside the Ollama folder after doing this step, git clone ollama.git, and I have moved the folder to Ollama. If you do this step again, since already I have Ollama folder here, if I do this again, the git will complain that there is already a folder I cannot proceed. So that's why I'm not executing this file. And after this, once you have done that, you need to do a git submodule init. So if I do git submodule init here, you'll see that it will ask me the modules. So I have done the git submodule init, and if I do git submodule update, and I have to call llama.cpp. So this folder is already present. So this update actually creates a submodule on this folder, and after that, once you do the update, it will start pulling this internal files from the GitHub repo. So I'm going to execute that. My only thing is I'm not executing it because I already have the various the next steps that I've already done. So once you do this step, it will pull the files from llama.cpp. It should not be, these are all pretty simple, straightforward processes. Let me now go into llama.cpp and let me do an ls. So llama.cpp has got a lot of files, and it is going to take considerable amount of time. The files that we are after are these two. So we have to create a quantize application, and we have to have the convert.py. So these two things are required. And in order for us to get this quantize application, what we need to do is we have to first of all create a virtual environment. So that's what we are doing. This virtual environment is inside the llama.cpp folder. You can see that here. It is inside the llama.cpp folder. If I do an LSA here, you will see there is a .venv file. It should be inside this. This is very important. Why I am telling it is important? Because this quantize file has to be inside llama.cpp. Don't pull it out. It will create unwanted dependency issues. So try to keep it inside the folder only. And even if you are using it in a GitHub repo, if you are trying to push and pull it also, the .venv files would have been already git ignored, so you don't need to worry about it. So you can keep the venv files inside. Once you have done that, you need to activate the virtual environment. So in order to activate the virtual environment, you have to use the source command in Linux and Mac, and if you are in Windows, you need to use a different method. You have to go to source, and I am already inside just a second. venv bin activate, and now I am inside the virtual environment. After I am inside the virtual environment, you have to do the pip install of LLMcpp requirements.txt. So this is the requirements.txt, and this requirements.txt is going to install the dependencies that will make the llama.cpp to work. So important point is, do not bypass the requirements.txt. So what will happen if you bypass this? I mean, if you don't go as per this requirement.txt, then it will the next steps that you are going to do, that is make -c llama.cpp quantize can actually error out. It needs all the necessary dependencies to be matched. So don't play with the requirements.txt. So use the requirement.txt that is provided here. Once that process is done, then you move out of this folder. If you are inside llama.cpp folder, move out of it, and from ollama folder. This is also important. You have to be in the ollama folder, and then you have to do make, and it has to be capital C, keep that in mind, and you have to do the llama.cpp, and you have to say that I want the make to create a file called as quantize. So once you do this, the compilation of this llama.cpp files, the C and C++ files inside the llama.cpp will be compiled, and you will be getting an application called as quantize, which you can use it for the next steps. Right. So I hope by this entire process, even if you are facing any errors, most of the problems that you will face will be there might be some issue with the network connection, or there might be some issue with your background operating systems, because when you are running this make -c llama.cpp quantize, what will happen is, if your operating system has some dependencies missing, like if it cannot do make, then you will have to install the necessary GC++ or GC compilers, and there are lots of separate videos for that. Next, we have got the quantization quantize file. What we are going to do next is, we have already downloaded the Starcoder model. Now we have to run this. You have to quantize it. So from now on, I will be following the steps one by one. Before we follow the steps, I want to show you the model. So let me show you the model where it is. So it will be, once you download this model through this Huggingface hub, Huggingface hub places the model inside the catch folder in your home folder. Huggingface hub models big code. So you will see the same .catch will be available in Windows also, but in Windows it will be under users, your username and .catch. So that also the folder name is .catch only, but you can see the folder directly. I'm not showing it in my Windows machine, but I believe that you can find it out in your Windows machine once you execute this code. So once you execute this code, you will be able to find it out. Fine. Inside the hub, what you need to be careful about is, after you reach this models big code star code folder, you will be surprised to see that there are no model files. There are these 3 folders. So inside the snapshots, you have to further go into the snapshots, and inside the snapshots there will be further folders. So you will see that every time you run the run this Jupyter notebook, what will happen is it will create snapshots, and these snapshots are updated. You can actually take a look at it like this, and you'll see that there are 2 snapshots. One is on February 29th and another is on March 2nd. Try to use the latest snapshot. So go into the latest snapshot, cd into the latest snapshot, and from there you have to start the activity. So this is very important. Okay, we are going to do the PWD on this particular location, and we are going to take the entire path. So where are you going to use this path? So let us go back to ollama folder. So I am in ollama folder right now. I am going to do a clear screen, and now what I'm going to do is I am going to execute this code. So I'm going to say moreover, I am already inside the virtual environment. You see that this virtual environment already has got all the necessary libraries installed during using this process. You should be inside the virtual environment when you are running this code. So keep this point in mind. So I have given the entire command here. I've zoomed in, so that's why you are not able to see, but in a single screen, but that's the entire command is here, but I'm going to execute this command also. So Python, I'm going to ask for converting the model first. So I'm going to say llama.cpp convert.py. I already showed you this convert.py inside the llama.cpp folder, and here I'm going to give the location of my models. So location of my updated model is inside this snapshot folder. So that's why I'm pointing that entire path to the convert.py. And once I give this convert.py, I need to give the out type that I want, what I want to convert the model to. So I have to give the out type, and I'm going to say I want to convert it to F16. So this is float 16 conversion that I am doing for the parameters, and then the out file, where I want the out file. So I want the out file inside the Starcoder7B only. So I don't want this out file in ollama. That will actually create a problem for me. So I need to again paste this, but this time I need to remove the snapshots folder. That's it. So once I do this, and once I execute this particular step, I need to give the name of the file. So I have say converted.bin. So it will create a bin file. So I'm going to execute this, and there is an error. So it's saying the file is not found. So if in case you get this error, so there are a couple of reasons you might actually get this error. So try to add a slash. So most of the time that could be one of the issues. If even after that it's not able to find, then you might have to change the you might have to change this snapshot folder. So even though you can see that the snapshot folder is containing these files, try to change the snapshot folder to a the earlier version. So try to change that and take this snapshot folder, because these are the kind of challenges that you will face when you are trying to work with these models, especially when you are working with Huggingface Hub. Just a minute. Outtype a coder catch big code starcoder converted.bin. So after I executed this with the earlier snapshot, with this snapshot, so what had happened was there was a problem with the RMS norm EPS. The conversion file that gguf is using is not able to convert the starcoder. This is logical, right? I am trying to work with a model that's very new, and most probably llama.cpp is not still updated. So this is my bad, but still I'm going to continue, and I am going to show you how we can do this with Mistral model. So I have already downloaded the Mistral 7 billion model also. If I go to the my model folder, just a minute, and I already have the Mistral model also. So I'm going to cd into the Mistral model, models Mistral. Yeah, so I have this 7 billion Mistral model, and you see that I've already tested it out with the Mistral models here. I have already quantized the model. I have already done the converted bin. So what I'm going to do is I'm going to remove this first. So I'm going to remove the, I'm going to, instead of removing, what I'm going to do is I'm going to give a different name, so that instead of using Mistral converted.bin or quantize.bin, we will have a new names here. So I'm going to continue with the process of converting the Python, converting the llama.cpp files. So let me do that. Python, and I'm going to call the location where I have the llama.cpp convert.py, and then I'm going to call my home folder. It's better that I give the complete path, and catch Huggingface hub, models, Mistral, and snapshots. So this is very important, and I'm going to go to this snapshot, and then I am going to say outfile is F16. No, sorry, the out type is F16, outfile is model converted.bin. So this model converted.bin, again I am going to place it inside the Mistral folder, but this time it is going to be model new converted.bin. So let me execute this, and in this case you see that it is executing without any kind of challenges, because the convert.py is able to load the model, and then it is able to convert it into F16, and then it is able to quantize it. Then it is able to write the bin file. So keep this in mind, it is not at quantized. So in order to quantize, you have to go to the next step. So in order to quantize, you have to use this option. I have to actually call the quantize application. So you see this step, I'll be showing it right now. So I have to call LLM llama.cpp quantize application, the quantize command, and then I have to give the location where my converted bin is. So this converted bin. So I'm going to do that right now. You don't need Python here, because I'm going to work with the command, the application that I've created. Quantize is there, and I'm going to give the location where my quantize model is. So model new converted bin, that is the converted model, and once I give that model location, then I need to give the output that I want. So I need to say new quantized.bin, and I need to give the quantization option, quantization specification. So I'm going to use q4_0, that is the quantization that I'm going to use. And once I execute this, you'll see that the quantization process happens. If there's an error in any of these steps, then it means that your quantization, the quantize application did not install properly. And once that is done, inside I'm shifting to the folder where I am in Mistral models. And if I right now do an ls right now, you will see that I have model converted.bin, and I have the new quantized also. My bad, the new quantized model, I had mistakenly placed it inside the ollama folder itself. So you can see the new quantized bin here. So I'm going to move it to the Mistral folder. Just give me a second. So I have moved the file. If I do an ls right now, you will see that inside the Mistral folder, I have the model new converted.bin. Next, what we need to do is we have to create a model file for pushing, to create the ollama model. So to do that, we need to come to this step. So create make file, and inside the make file, we have to do some editing. So I'm going to touch, and I'm going to create a new Mistral. This is a file that I am touching, and this file will be already available in the folder. Now I'm going to edit this file. So this is how we do it in Linux. So I'm going to edit this file and I'm going to use this format. Basically, I'm going to use the new quantized bin that I already have, that I created right now. You see the reason why I moved that new quantized.bin to the local folder, because in order to use this from command, the quantized.bin should be in the folder where the model file is being executed. So this might actually create some kind of a confusion. So that's why I am not changing the steps here. So you also do not change the steps. Ensure that the files are in appropriate location. And following that, there's a template. So this is the prompt template for doing the generations. So this is not the prompt template for chatting. So if you try to use this for chat model, then this prompt will create weird outputs. But this is for generation. So I will show you what I mean in a couple of minutes. So let me complete this. I'm going to save it and I'm going to come out. So right now, if I do a cat on new Mistral, you'll see that the file has been updated. I think I made a new quantized.bin. So that is right. Once I have got this file, new Mistral file, all I need to do next is that I have to load this model into Ollama. So before I load this model into Ollama, I will run the Ollama command and I will list. So you'll see that already I have a couple of models here. So I have Gemma 2 billion that I used in the earlier video, and I have these two models that I already created. So these models I created for testing. Now I'm going to create a new Mistral Q4, right? So you'll see that I will have a new model after this process. So to do that, I'm going to use the Ollama create. So you can do a Ollama h. You will see the various commands available inside Ollama, and Ollama create. I need to, once I use the create, I need to tell the model name I'm going to use. So I'm going to use new Mistral Q4. So this is the model name that you will use for invoking the model, and I have to give the model file that I created. So new Mistral file that I created right now. So this is the file that we created here. You created this file here, right? So this is the same file that we are going to use, and I'm going to execute, and it is transferring the model data, and you will see that it is creating the model layers, and after that it will be listed in Ollama right now. You will see that it is writing the manifest and it's success. It's showing success. So if I do a Ollama right now and list, you'll see that there is a new Mistral Q4 latest model present, and it's 4.1 GB of size 8 seconds ago. Now the model has been loaded into Ollama. Excuse me. Okay, so we are able to see the model, but can we use the model? So that's the purpose, right? So in order to use the model, you have to do Ollama run. And we are going to use the new Mistral Q4, and just a minute. So new Mistral, you don't need to give new the latest here. It is by default understood. And once I run this, you cannot run it and just leave it, because if you run it and leave it, what will happen? You will go into the chat mode. So usually this is the mistake that I made, and I will show you what happens. So explain Big Bang Theory. Okay, this is Big Bang Theory. So here you can see that it is able to execute properly, and it is able to chat with us properly. And the issue that I was facing is, so let me see, complete 1, 2, 3. You'll see sometimes it does not respond at all. So what is the when did Big Bang happen? Again, you will see that it is also not providing a very good output, right? But you see this output, this kind of output starts coming when you are using it in chat. So the format that you have used is not for chat, so you need to use it in the generation only. So ensure that once you run this, you provide the update, the prompt here itself, not the update, sorry. I'm giving this big bang happen, and you'll see that it is able to provide the updates here itself, and you don't need to actually go into the what is it called, chat version, and then do it. And the model is pretty fast. The reason the model is pretty fast is I am already running it on GPU, and it doesn't stop because we are trying to generate, and we have not given it any kind of a control mechanism. So once that entire thing completes, then it will stop. So you can see that the model is loaded, and let me go here. So we have gone through the entire process of getting the llama.cpp and ensuring that we have installed llama.cpp supporting libraries. Then we create this quantize app. We tried downloading Starcoder, and we tried quantizing it, and it failed because of the dependencies issues, and also the Starcoder model is a new model. The llama.cpp was not having the necessary dependencies, and then we started working with the Mistral model. In Mistral model, we created the bin file first using the convert.py, and then we quantized the file using the quantize app application that we created using this particular command. Following that, we got the new quantized bin, which we created a make file using the vim in Linux, and then we created the ollama model using that make file, and then finally we ran the ollama model. We went into the chat inside the ollama model after you did the ollama run with the model name. You went into the chat, we tried it out, and finally we gave the generation, the prompt, what is big bang theory, directly on the command prompt itself, and we saw the output that you look here. So we have done this entire process. I believe that you have learned a thing or two from this discussion. Do leave a like, and if you have any questions, do comment it out, and I will try to provide my feedback. I believe the way we are actually moving between the folders in Linux will be a little bit of a challenge for you guys to follow, but try to review the video once and see what is the process, see what are the errors that you are facing, with that I am facing. And then once you are familiar with it, once you understood what is happening, then you can do it by yourself using this process. So the intention of the video is to show you what is going to happen when you are going to execute these files, execute these commands. In that way, you will get the confidence, and you can go ahead and enjoy the large language models through Ollama, and you can start serving it also. I'll be further continuing with these discussions with connecting to Ollama with various other apps in Python, in DSPy. DSPy is one of the new libraries that I am also going to explore. So stay tuned for these videos. Till the next video, I would like you to do quantize, prompt. See you guys. Have a great time.